I will be quickly going through this topic so we can have some discussion and most important thing, the coming dinner today. Okay? So I'll be sharing with you something about auction-based federated learning because for today's talk, I think we have laid enough groundwork leading to such a topic where we know about works that focuses on data valuation, contribution evaluation, incentive mechanism design, and I will put in one piece of the puzzle towards building auction-based federated learning systems. Okay? So here's my contact information. If you have any questions you wish to discuss with me, I always respond to emails very fast as long as I'm on the ground, not flying. Okay? So our work, the works I'm going to introduce today mostly come from our research center, which is founded by Brian's office in AI Singapore. We focus on developing trustworthy federated ubiquitous learning technologies, which encompasses areas including trying to interpret various models and processes under federated learning settings where we can't look at the raw data, laying groundwork for some contribution evaluation and data valuation techniques in terms of fairness, how we design incentives, how we design client selection and team building processes in order to offer equal opportunities for people who are trying to participate in federated learning as well as people who are trying to access data owners who have data to share. In terms of robustness, the focus is wider, trying to take care of attacks and defenses in federated settings, as well as scaling up and efficiency building, especially in the eras where we either face large number of devices or larger scale models that are emerging. So going into the topic of auction-based federated learning, actually multi-agent-based auctioning has been widely used nowadays in internet advertisement auctioning. So whenever you are opening up a web page, there could be an area designated for showing an advertisement. After 1 or 2 seconds of delay, you see the ads being displayed to you based on your taste, based on analyzing your profile with the cookies. That's why they are so keen on you accepting cookies in your web page. And also, based on the interaction of thousands of agents, each representing an advertising agency with a specific goal, specific type of target users they want to attract, as well as a specified return on investment they wish to achieve over the long run. And each individual agent representing them would try to come up with a decision in terms of whether they want to compete by giving an offer for this advertisement space and how much they wish to price that in competition for it. And once the auctioneer collected all this information, they will follow a given auction mechanism to determine who is the winner, charge that winner for whatever premium they need to pay, and then display whatever set advertisement that winning agent is supposed to put there. Okay? So we wish to build something similar in multi-agent empowered federated learning system. So when we are talking about federated learning nowadays, when we are doing research, we have various algorithms about how to select clients, how to aggregate models together, how to build personalized models. But before that, we need to determine who should join whom in terms of forming a team to perform federated learning. And auction-based mechanism could be a way to address this problem. And the aim here is that we wish to build a multi-agent empowered system where people don't have to worry about making such decisions manually. They could have their representative agents, each representing their goals, which they express to the agent in terms of some objective function the agent could optimize. And then through multi-agent interaction, the auctioning process could be carried out. So for such an ecosystem, there could be these 3 types of stakeholders involved. We have always, may not always be, but most of the time we'll need an auctioneer somewhere as a trusted third party who take care of this whole ecosystem, determine who wins, disseminate information, as well as trying to maintain the integrity of the system in case someone eventually would misbehave, trying to find ways to game such a setup. We would have data consumers or model users. Sometimes you call them model users, but essentially they are servers in our federated learning lingo, who wish to spend their budget wisely, engage in useful data owners that can help them train models to accomplish their tasks, and do this as quickly as possible, as efficiently as possible. We will have data owners who have data resources to sell. They will also need to commit some local compute resources in order to participate in federated learning. And of course, what their goal is to earn as much income as possible based on their resources they commit. Okay? So for such a setup, if we take an overview of the key steps involved in here, say for this case, this would be the forward auction case. We would first see that the data owners would come up with bid requests submitted to the auctioneer to say, okay, I have something to sell. I need to tell the auctioneer some information about my data set. Of course, I'm not going to copy my data set to anyone else. I'm not going to expose the details, but I need to give some meta information, like what kind of data I have, how many data points I have, and what kind of quality I think my data is. And the auctioneer would say, okay, I now get your bid request. Now I can do information dissemination about this bid request. And I know someone having a resource to sell. Here, we can do a lot of algorithmic research in this area to see, okay, the information dissemination doesn't have to be broadcast to everyone involved. We could do some kind of control here to say, okay, based on observation of previous interactions, the auctioneer might expose this information to select groups of buyers in order to equalize the chances of buyers accessing high-quality data owners over the long run in order to maintain some sort of a fairness objective. Okay? Once information is being disseminated to model users or data consumers, they will say, okay, I look at this data resource, look at my budget, look at my goal. Do I want to bid for this person? If yes, how much I should bid for this particular person in competition with potentially other buyers. And when this information is eventually all coming back to the auctioneers, they would follow a certain auction mechanism to try to determine who wins this data owner. In some cases, one data owner could be potentially multitasking. They could potentially, if they have enough local compute resource, if they can manage it efficiently, they might be simultaneously engaged in multiple training tasks in federated learning. That's also possible. There's another level of complexity we might consider. The type of interactions currently being studied in the AFL literature can be divided into these three major groups. We have the reverse auction, which is a sort of a simplified case where people assume there's only a monopoly market. There's only one buyer in the market. And all the sellers, they're trying to compete against each other to lower their bid so that they can attract this buyer's interest to getting selected. That's the reverse auction case. Forward auction is slightly more realistic in this case. We say, okay, we acknowledge there could be multiple buyers simultaneously competing for the same pool of sellers. And then in that case, it would be the buyers who would need to come up with their bid to try to outbid each other in order to attract from the same pool of data sellers. There could be cases where we can engage in combinatorial auctions, where the data sellers, they could band together to say, okay, maybe we band our data resources together into a packet, into packages of different data resources that can be particularly valuable for certain more complex tasks, for example, that requires multiple modalities of data. They can sell this bundle together for bidders to compete for. That would be combinatorial auction case. Of course, there would be cases where reverse and forward auctions are being combined together. Both parties are trying to bid against each other. That would be the double auction cases where theoretical optimalities is more difficult to analyze. So with that in mind, I will quickly go through some of the representative works that we have participated in these areas. So most of the current available works in the area of designing multi-agent system-based federated auction-based federated learning is focused on serving the purpose for the data consumers, serving the requests for the model users. So for this work, this would be a simple starting point where we try to get all these automatic steps done. We build agents that can take previous bidding data as the input to try to see your winning track record from your previous offerings, and then try to use reinforcement learning to see how I can adjust future bids that I want to put out for attracting, maximizing my chance of winning. That would be a simple starting point. And later on, people talk about, okay, maybe in those kind of works, not only just one work, in that category of work where we focus on automating the process, they start by thinking about maybe we spend our entire budget in one go to assemble the entire team and then start training. That may not be the most wise way to do things. Maybe for your instance, when you're trying to hire people, most of the high-quality data owners, they are fully engaged in other tasks. You have to bid for low-quality data owners. Or maybe in that case, a lot of other model users are trying to compete for the same pool of data owners together with you. The level of competition is too high. So in the second category of work, people start to think about maybe we do it in a multi-session way. Maybe we don't spend our entire budget in one go. Instead, in planning-based approaches, they're trying to pre-plan. So how many chunks should I divide my budget into? And then they try to minimize my chance of being engaged in very abrasive competitions with others. So in this kind of works, you would have to determine in advance how many different chunks I want to divide my budget into, which may not also be flexible enough. So there are other works that emerging that is thinking about what if we model this whole process as a hierarchical reinforcement learning process over time, so that in each point in time, we would learn to determine what's the percentage of the total budget I want to utilize for this current session to hire the number of people that I need to engage in training. Of course, along the way of engaging people, you don't wait for the entire team to be assembled before you start to train. Instead, once you have a few, you start to train and you monitor whether the model itself has achieved the level of performance that you target, whether you can stop hiring others earlier in an attempt to save more budget. There could be also other opportunities where we can do without a centralized auctioneer, because the centralized auctioneer could be a central point of failure as well. So in this case, we also investigated in this platform about what if people are related in a network of trust or network of acquaintances. Nobody knows everybody else. Each body knows someone else who can potentially propagate information about your intention of initiating a federated learning task and helping you find other potentially useful data owners through a referral network, something similar like this. When you go through a different referral paths in order to eventually find out who can potentially be the most useful data owners for you, and they can win auctions through this way. And of course, in that way, you also need to take into account the referral cost that you need to pay for information dissemination in order to reach your target users. So for the auctioneer part, there's some work, but for the auctioneer part, they're not really concerned about optimizing the payoff for either parties involved. They're mostly concerned about performing certain internal governance within this environment. For example, in this work, we're talking about the information dissemination stage, about trying to achieve fairness among the bidders, among the buyers. So in this case, we use some sort of a tracking approach based on Lyapunov optimization to track the level of regret that the buyers have accumulated over previous rounds of auctioning. If they fail previous rounds of auctionings, we might add some more regret on that on their queues, so that over time, we would also take this into account to say, okay, this person has repeatedly started to bid for data owners, but due to either budget limitations or some other unforeseen circumstances, they never really got what they really want. So eventually, at a certain point in time, we would try to direct information about high-quality data owners' availability towards those smaller selected groups of data owners, buyers, to maintain some sort of fairness. And in this work, we are thinking about extending that situation because that kind of situation, where we talk about taking regret into account, is akin to a prior-based auction mechanism, which we know prior-based auction mechanisms, they are open for misbehavior, open for people to game such a system. So in this case, we try to look into how we can break up potential collusion rings in such an auction system. We would deploy certain spy agents from the auctioneers. We call them bar agents, who essentially they get attached to each of the bidding agents from the buyers to try to learn the patterns of bidding over time and ascertain whether they are potentially colluding together to try to depress the bidding prices in an attempt to leverage such a system. That's pretty much the current situation about multi-agent-based federated learning through auctions. So far, we don't see any work that's designed for the data owners yet, but that's an area that we can focus on. Just a little bit of final advertisement at the back. We have a workshop coming up in New Rips, 16th of December this month, talking about federated learning in combination with the foundation models, large language models. Very interesting work already accepted, 38 papers. We can take a preview about what people are working on. If you miss this chance, don't worry. We have another one coming up in Singapore this time during Triple W. Same topic. If you are interested, deadline is 5th of February. There's still a lot of time. Also, if you are really interested in going to Japan, we have another special session on this topic in IJCNN. Thank you very much.
Thanks, Han. Any questions for Han? Cool. Then,
is there such an auction set up right now? This kind of auctions for data. Do you know of any?
I have to take some slides out of the deck to fit in the time. We have not as complex as this one, but a basic auction-based federated learning system set up in collaboration with the ENN Group, which is an energy trading company in China. They have a lot of subsidiaries as well as companies that are collaborating with them with data to be shared, mostly about energy trading. They talk about procurement of gas for power generation, and they need models to predict demand for gas at different times, different areas. And we have sort of set up a very simple auction-based multi-agent trading system with them for trial. We have a hierarchical incentive structure deployed with them for trial over the past 6 months already. There's a paper coming up in IAI this year, and deployed application track about this. So very simple approach, but the result is very interesting. They use a little bit of budget, like 60,000 yuan in China, but the incentive actually is directly disseminated towards people who are working in the front line to try to incentivize them to improve effort in terms of data collection and cleaning and labeling. And we can see that they get really excited about having such an opportunity. It's very novel to them. And we were able to improve the model performance by like 12 percentage point. And on the best day, the model can save the operation about 120,000 yuan in terms of gas procurement cost. So there's something starting to take shape over there. And there might be others I may not be aware of. There's another question at the back.
Alexei Tumanov, Georgia Tech. Very interesting work. This is a very sensitive microphone, sorry. Very interesting work, and it's really exciting to see the implementation of actually some of the ideas that Mike Jordan was talking about, like in 2019, essentially developing economic models around the data producers, data consumers, and as well as the models that are being trained on top of that. One of the challenges there is to actually come up with a declarative taxonomy for the data sources. Because you actually need kind of the auctioneer to be able to perform this matchmaking process, which means that you're dealing with some sort of a declarative schema on both producer and consumer sides. So what is the state of the art there? I'm trying to get a sense, like, are you moving beyond just specifying data sets, which are, or some sort of nomenclature for the data sets these data sources represent, or can we move past that point and have a much more involved and much more meaningful taxonomy for data sources?
Yes, that's a quite important question. So I know of some work in that area. Provenance about data is one area where we put descriptions on the data, but there is a branch of work in contribution evaluation which is based on trial and error. So they give some opportunities for people who are they are about to hire, using a sandbox to perform trial, let them join a few rounds of training to see the real impact of the data set on the model performance. And from there onwards, they either engage sharply value-based contribution evaluation, which is hugely computationally costly in that case, because you still have to think about retraining models, combining different submodels together. There's a line of work branching from there, trying to improve the efficiency of this by performing pruning. And also, that's for the horizontal federated learning setting. In the vertical setting, you're talking about not only not data samples, but about features. People are coming from different business verticals. They are holding data from different features. So there were works coming up trying to perform feature selection and using the number of features being selected eventually for model training to training the vertical federated learning models to determine the contribution from the users. So on top of letting people declare what kind of data quality it is, people are starting to perform trial and errors or through reinforcement learning to really try to see how their impact on the model is. And some even combine that with some sort of a reputation mechanism as a retribution. If you claim this kind of a contribution after we tried your data set, doesn't really match that, there's some consequence on your reputation, which is taken into account for future engagement. Of course, there's also the field of contract theory, where we can design different contract structures for people to choose different contracts, and then that will also have consequences if they cannot fulfill the contract later on. So that's what I understand about the current field now. Thanks.
I think that's also a good question for the panel discussion, because it's a very general question. Yeah. Maybe let's thank Han.
Okay, thank you.